Welcome, my name is Craig Otto. This is Statistics for SPC, Operational Excellence, and we're getting into the last part of hypothesis testing, which I'm sure is greatly disappointing to you. But just have a few more tests I wanted to share. These are a little bit different than the ones we've seen in the past. That's why I kind of separated them. Basically, we're going to talk about chi-square and also the F distribution test for today. So with that, we'll go ahead and get started. Again, chi-square, that test can be used, or that distribution can be used for several different things. Basically, what I'm going to show you is something that's called chi-square test of independence. And basically, with the test of independence, you have a null hypothesis that events are independent, and the alternative is that they're not independent. So in this example here, what I've shown is that we're comparing two different things. We're comparing the amount of money spent compared to the number of elected officials, whether they're Democratic or Republican. And what we're trying to determine is if each of the parties spend less than 10 billion, is there a difference in people elected versus if you spend more than 10 billion? And we're trying to see if there is a correlation between those two variables. If they're independent, that means that there basically is no correlation. But if it's not independent, that means that there is correlation. They depend on each other. So with that, I'll go ahead and get started. Basically, when you do a chi-square test, you have observed outcomes, okay? And that's what I have here. Basically, these four boxes here were observed. So for projects that were less than 10 billion spent, there were 23 Democrats and 31 Republicans. And for ones that were greater than 10 billion, there were 22 and Democrats, 16 Republicans. And the way that you do this with this is called a 2 by 2 because it's 2 by 2 across. With these, what you do is you have like a column total and a row total. These are always added in after you get the observed data. And the column total is exactly what it is. It adds up to 23 plus the 31 to get to 54. Same thing here, 22 plus 16 to get to 38. And row total is the exact same thing, only you're adding the rows. So 23 plus 22 is 45. 31 plus 16 and 47. Okay? And then the column total and row total both equal 92. So 45 plus 47 is 92, and 54 plus 38 is 92. Okay, now in order to determine if there's correlation between these, we have to have sort of an expected outcome. And what that is it's a calculated method. You can see here what you do is from the observed, so you have to have the observed before you can get the expected. What you're doing with the expected is you're taking the information from the observed. So like the 45 and the 54, you can see 45 and 54. What that does is you multiply those two and divide it by 92, and it'll give you an expected number for this 23. Okay. Do the same thing here. 47 times 54. You can see the 47 across, 54 here, to get an expected number here. Kind of see how that works? 45 and 38. 38's on this column, 45's in this row. That gives you this intersection between those numbers, gives you the expected number here. And you just divide that by 92. So 45 times 38 divided by 92. Same thing here. This one is 47 and 38. See where those two numbers intersect is this particular cell. So 47 times 38 divided by 92, which is just the total. You can see in all 4 of these are divided by 92, which is the total. And when you do that, it'll give you an expected frequency. Okay, so I'll just do that real quick. So those numbers, when you do the math, should come out to these right here. Okay, this is very important. You have to know how to do this. There will be test questions, quiz questions on this. I think they're true or false if I remember right. But you got to know how to calculate this in order to know how to answer the question. So just make sure you're aware of how to do that. Okay. And then what we do is we actually take these 4 numbers, these 2 by 2 up here and 2 by 2 right here for expected, and we plug them in on a calculator. Before I do that, I'll give you some examples on how that gets plugged in and different things, but I want to make sure you knew how to calculate this expected frequency, because that's important. Sort of a change in subject. There's also what's called a goodness of fit test. I mentioned the chi-square distribution can be used for many different tests. It's important to know, I know there's quiz questions on this too. We're not going to get into goodness of fit, but it's important you know that it's out there. It exists. And what we use goodness of fit tests for is to prove, that populations either fit a distribution or it doesn't. So these are very useful as well when you're talking about trying to determine if data meets a normal distribution or any type of distribution. The chi-square is a good test to use to do that. Okay, and with that I'll get in. So now that we know how to do that calculation of getting the expected, we can start utilizing the calculator to get an actual outcome here. So with that, if we just click on any one of these different links, the first one, the chi-square test, again, what we're trying to do is do tests of independence. So I'll go ahead and click on number 3 here, tests of independence. So here's an example. This just happens to be a 3 by 3. We did a 2 by 2, and what you do, and I mentioned H sub O is that they're independent, and H sub 1 is that they're dependent or not independent. So the way that you do that is you have to type in on your calculator, you're basically you're observed. So they went out and they typed in these 3 by 3 numbers here. So 91, 39, 18. You can see down here 91, 39, 18, and then on down. But they do not type in the totals. Okay? So do not type in the totals. Alright. Now, to get the expected, you have to go in and figure out the expected. So if you remember right, so in the first table, the first matrix, to get into matrix, basically, let's see, on your calculator, you should be able to get in and have a matrix function button. And when you get in, when you hit that matrix button, basically what you want to do is just hit edit, okay, and then select the first matrix and type in your observed, and it's pretty straightforward. So you select that matrix, you type, it should say 2 by 2 at the top, or whatever, however big your matrix needs to be. In this example, it's a 3 by 3, but you just type that in. If it's 3 by 3, you just hit 3, enter, and then 3, enter, and it gives you a 3 by 3 matrix. And then you just type in whatever the information is for the observed. Okay. Now once you have that in there, you just go back to the matrix again and hit edit, and this time you just select matrix B, and in matrix B you select that, hit enter. It should say a size, if it's 2 by 2, whatever it may be. But if you need, in this case, a 3 by 3, you just hit 3 enter by 3 enter, and it gives you that 3 by 3 matrix. And what you put in this matrix B is the expected. Okay, so if you remember how we got the expected on this particular example, they would take the 430 times the 148 divided by 800, and that works out to the 79.55. And they just keep doing that. So for this particular one, they'll take 430 times 208 to get this cell divided by 800, and that works out to 111.8. So they do that for each one of these. They calculated it out, every one of them, and then what they do is they type that in matrix B. So you can see the 79.55 here, 111.8 here, 238.65. So you can see what they're doing. Now once you have this information typed in on the matrix, now you can actually do the test. Let's see if they show that down here. They show you can do in Excel too, which is fine. Let me find the example here of where they type it in on the calculator. Here we go. So once you type that information in, you're going to go to the stats button. You're going to go to test. Let's see if they show here. Yes. Go to the stats button, scroll over to test, select the chi-square. That little looks like an X with the 2 behind it. That's your chi-square. Okay. You want that test, and then it'll come up a picture like this, and you've typed in your A matrix and your B matrix. So you should, as long as you type the observed in A and expected in B, all you have to do is hit calculate. Okay, and then what it'll do is it'll dump out the chi-square test statistic and a p-value, and that p-value is just like all the other p-values. What you do though is you treat the chi-square test like a one-tailed test, so that you don't have to worry about, like with two-tailed tests, you have to divide it by 2 for the critical value and all that. This is much simpler. It's just assume a one-tailed test. P-value, critical value is 0.05. So like in this example, 0.01 is less than 0.05, so you would reject the hypothesis, and meaning that the variables are dependent. Because remember, H sub O, the initial or null hypothesis, is that they're independent, and then if it's rejected, then it's dependent, meaning the variables depend on each other. Okay? So it's a little complicated, but as far as the test goes, as long as you can enter the data into the matrix, you should be okay, because the test is pretty simple. You can see you just put the observed in, expected. It's also a little tricky if you're not sure how to get the expected, but again, it's you just multiply the row sum times the column sum and divide it by the total number, and that'll give you your expected by cell. Okay. Alright. I mentioned the goodness of fit test. This is just some information on that. I don't expect you to know how to do any of this for the exam. Again, I just like to pass information on like this for those who are interested. Okay. Alright, now I want to talk about the F test. Basically with the F test, you're just comparing two different distributions. Well, they could be the same. You're trying to determine whether the variances are equivalent or not equivalent. Okay. So in this example, we have a large variance in blood chemistry components, and that can result in health problems as the body attempts to return to equilibrium. So in this case, they had a sample of 10 non-pregnant women, and the variance ended up being 211. And in 8 other pregnant women, the variance was 196.21. And what we want to know is the variance in the glucose levels between the pregnant and non-pregnant women the same, or the different? Are they different with 95% confidence and then with 99% confidence? Okay, so in this case, our initial hypothesis, or null hypothesis, is that the variances are the same. So we're assuming like the 211 and a 196 are equivalent. If we prove that they're not, or reject the null hypothesis, that would mean that they're not equivalent. Okay. So basically, what we want to do is in the calculator, we'll go to Stat. We'll scroll over and look under Test. Go down to the, should say, to sample F test, and when you hit enter, you'll have some items to enter, and that's these two items, your different variances here. Pay attention to the sub 1s and the sub 2s. We had a sample size of the first of 10 and the sample size of the second group as 8. Okay, and then when we hit calculate, just make sure you also choose the not equivalent. So when you hit calculate, you have an F value of 1.159, and that converted to a P value is 0.8654. So with 95 and 99% confidence, we are easily able to assume that these variances, we cannot prove that they're different, because the P value is significantly higher than 0.025 for 95% confidence, and then 0.005 for 99%. Again, it's two-tailed. That's why it's not 0.05 and 0.01. You have to divide that by 2. So answers, again, fail to reject for both cases. Okay, well, that is the chi-square and the F test. That'll actually conclude most of the hypothesis testing. We will do something called analysis of variance next time, which is also a type of hypothesis testing. So just as you thought you was getting away from it, it's coming back. But that's next time, and I believe we'll have a midterm here over hypothesis testing so far. And the biggest thing to remember is, write down your givens in the problem, and then once you have them written down, just assess and write them in this fashion, just like I did. That's why I set these problems up this way. Write down your null, your alternative, and then write down all the givens that you have in the problem, and then have that help you choose which test to use. Because I'm not on the test, and as you've noticed in the weekly quizzes, I don't tell you what type of test to use. I just say, here's the information. Is it equivalent or not with a certain level of confidence? So the biggest thing to help there is just write this information down and use that to help you figure it out. So, all right, with that, that'll conclude the session.